So this is uploaded in Schoology, so you can print this out and look at this. We're going to work through some of this together today. So multiple choice practice. But I want to start with the third page of it, and that is this graph, and this is the graph of f of x. I do not like that it doesn't say that. This is the graph of f of x. It says, using the figure below, complete the chart by indicating whether the functions are positive, negative, or zero at the indicated points. So let's do A together, and then I'll leave you for a few minutes to fill out the table. So here's point A on the graph of f of x. And all I'm going to put in these blanks are plus, minus, or zero. So at point A, is the function positive, negative, or zero? Negative, because it's below the axis. At point A, is the derivative positive, negative, or zero? Why is it positive? Because f is increasing. Or we could be looking at, you could think about the slope of f. And then how about the second derivative at A? Why negative? Because it's bowled down. So second derivative talks about concavity. So take a few minutes. Some people like to go like point by point, like we just did. Other people want to be thinking just positive, negative, and answer all of them, and then think about slope and answer all of them, and then think about concavity and answer all of them. Doesn't matter to me. Take a few minutes, fill out the chart, and we'll see if we agree. All right, so for our friends watching at home, there's the answer key, and again, you're just looking at above or below the y-axis. That's kind of an easy one, or x-axis, excuse me. Then look at the slope, then look at concavity. And again, that was a question from the AP test. It wouldn't have been worth a ton of points, but it should be an easy one. Okay, good on that? Yes?
When would the second derivative be 0?
Good question. When would the second derivative be 0? F double prime equals 0. Well, it would be obvious that it was 0 if it was a change in concavity. So at those little X's on there, those are points of inflection. So yeah, those would have a second derivative of 0. So good question. But it didn't put any points at those. A lot of times they'll label the POI, or they'll make it clear that it's away from there, because it's really hard to tell. I mean, it's easy to tell where a max and a min is. It's hard to tell, like, where is the point of inflection? Does it change right there? Or does it change where the X is? Or does it change down here? Like anywhere in there would be okay. That's why they labeled it. It's also why they kept the points away from it, to make it a little easier. They labeled it here because, I don't know. It's hard to tell exactly where it changes if you're looking at a picture. So a lot of times they'll put the point on there to make it clear. All right, next one I want to do together is number 1. So flip all the way back to the front. And this is a pretty common question on AP tests. I'm almost positive you'll get something like this, where they give you the derivative, y equals f prime, and they're not trying to hide that fact. That's not a secret. The graph of the derivative of f is shown in the figure above. So they're trying to remind you that picture is not f. That is the picture of f prime. And that's what throws people off on these problems, is you have to really be careful if you're looking at a graph of f prime. The question is, which of these following graphs could be the graph of f? Well, I don't know. Let's take a moment with the graph of f prime and see what we can learn about f from the graph of f prime, and then maybe we can apply what we know to those pictures. So I don't really even want to look at the pictures yet. I just want to think, something's going on at -1. So what would you say about f based on what we know about f prime at -1? Let's say something about f prime first then. Why is that even a point of concern here? What is f prime doing? I mean, it is decreasing, but what, even easier than that, f prime is changing from what to what? Positive to negative. Okay, as we move left to right, f prime changes from positive to negative. Now, you almost have to cover the graph up because it's hard to visualize like two things at once. So, not looking at the graph, but if f prime changes from positive to negative, what does that mean f is doing? Or what's going on at f? So f has a maximum. And again, it's really, really tricky, especially when we first get started, like we are now, to look at this picture and say that f has a maximum right there. You're like, why in the world would it have a maximum right there? It's just like crossing through the axis. But you have to slow down and think what's going on. F prime is changing from positive to negative, so f has a relative max at -1. So that'll help us when we get to the pictures. In fact, we could use that and start ruling things out. At -1, I want a relative max. A is not really it. There's a relative max close, but it's not at -1. So A is out. B does have a relative max at -1, so that's a maybe. You guys know how multiple choice questions work. We got to check them all and see how things look. C has a relative min at -1, so that one's out, but you can see why that's a choice. Like if somebody got things backwards, they might pick C. D also has a relative min at -1. I'm also suspicious of the straight line, but who knows? That one's out though. And then E has a max at -1, so I can put a check at that spot. So A, C, and D are out. B and D are, or B and E, excuse me, are maybes because they got a max at the right spot. Let's see, what else do we know looking at F prime? What's going on at x equals 1 in terms of F or F prime?
Minimum.
It's a minimum. F has a minimum because F prime changes negative to positive. Again, it's going to be a while before you look at a graph and just immediately know. Like for now, you got to slow your brain down and think. F prime is changing from negative to positive. Negative to positive, that means there's a minimum there. Again, once you've done 100 of these, maybe you'll look at it and know them right away, but you're not there yet. I'm not really even there yet. Slow your brain down. Don't be tricked by the picture. F prime changes negative to positive. F has a minimum at 1. So let's go look at our choices. Minimum at 1. Yep. So we're still okay with B. E, crud. It also has a minimum at 1. So that didn't really help narrow things down. What's up?
Slope is changing, it's not a straight line.
Slope is...
F prime is changing, you can't make a straight line.
Okay, so now you're kind of thinking the other way. Like looking at here, I like this. This has a constant slope equals, I don't know what it is, constant negative slope. Yeah, because this is a potential F. Its slope is negative. That means F prime should be negative. So I think we could use that to throw out E. if you want to kind of check that over here, our slope f prime is greater than 0, less than -1. That matches. Color code this thing. When we're decreasing, that means f prime is less than 0. Yep, that matches. I mean, I'm convinced it's B now, but I'm just finishing the problem. From 1 on, f is increasing. That means the slope is greater than 0. And that matches what's going on over there. So a lot of things to think about to match those up. And that's a good sample AP problem because they throw a lot that are concept based. Like you didn't have to take any derivatives on that. You didn't have to know the product rule or the chain rule. There'll be plenty of times we test that, but we can also test just concept questions. Questions on that one? All right, I'll leave the rest of the multiple choice for you to do. There's a couple more graph matching type problems. A couple other good questions. I mean, they're all good questions, but things you might see again on test day next week. Let's go to the very back and look at the first multiple choice question. Or excuse me, the first free response question there. These are very common. This type of free response question is very common. And so here's two from previous tests. It's not every year they have one like this, but it's pretty frequent that they give you a graph of f prime and ask questions about f or f double prime, because there's just a lot of information there. And that's why we spent 3 days saying the same thing as many different ways as we can, with warm-ups and worksheets and popsicle sticks and phrasing things forwards and backwards, because we need to be able to look at a graph of f prime and answer some questions. Again, graph of f prime, the figure above shows the graph of f prime. Like, they don't want you to miss that this is the graph of f prime, which is the derivative of the function f. I don't know that needed to be said, but okay, one more time, this is the derivative. On the interval from -1 to 5, the graph of f prime, so this is the graph of f prime, has horizontal tangent lines at x equals 1 and x equals 3. Okay, that fits. I would buy that. The function f is twice differentiable. That just means it has a second derivative. And f of 2 equals 6. Okay, f of 2 equals 6. That doesn't go on the graph because this is f, not f prime. And if it tells me this, I'm guessing I'm going to need that later on, but it doesn't really make, I don't know. I don't know what to do with that information right now. Part A, find the x-coordinate of each of the points of inflection of the graph of f. Give a reason for your answer. In my mind, you always want to give the reason first, because then that tells you what you're looking for. It also, I'm going to give the point breakdown on this in a minute, but you could also get a point on this problem if you get the reason right, but your answer is wrong. Okay, so that maybe feels weird you could get it sort of backwards and still get a point for it. But if you give the reason, but then kind of mess it up from there, you can still get partial credit. So points inflection. What is a point of inflection? Not on this graph, just in general. What's a point of inflection?
Double prime is 0.
F double prime equals 0. That's almost right, because it could be negative and then go 0 and then stay negative. So it has to change signs. And so really it doesn't have to be 0. It could be 0 or undefined. What we really want is it changing signs. Okay, but I don't really have f. I mean, that's the correct statement, but I would like to give a reason in terms of f prime because I have a graph of f prime. So you want to give a reason in terms of what you know. So, I mean, this is a fine first statement, but we need to sort of tweak that so that it's in terms of f prime. So how is f prime related to f double prime? Or how else could I state f double prime?
The slope of that point is 0. You said it equal to 0.
I'm going to get away from the equal 0, but I do like slope of f prime. Because slope of f prime, that means the same thing as f double prime. Because slope means derivative. So what you really wrote is derivative of derivative, second derivative, changes signs. Well, now we're ready to go because we have a graph of f prime, so we can look and see where the slope changes signs, where the slope of f prime changes signs. So I've reworded the question to be in terms of my information. So at what x value does that happen? Where does the slope change signs? Good, at 1, because it changes from positive to negative. The slope does. Where else? At 3, it changes from negative to positive. Give a reason for your answer. Well, I already gave the reason. The slope of f prime changes signs. And slope of f prime means f double prime. If f double prime changes, then we've got a point of inflection. At what value of x does f attain its absolute minimum value? At what value of x does f attain its absolute maximum value? Show the analysis that leads to your answers. Okay, so let's first sort of answer the question without regards to the details of this one, and then we'll use kind of what we know and look at what we've got, put the two together. How do we find absolute mins and maxes? Okay. Critical points is part of the answer. What else? Intervals, maybe. What other points do we need to consider if we're talking about absolute? Endpoints. And what do we usually do with those critical points and endpoints? Put them on a table. So let's do that and see what happens. Endpoints, that's easy. -1 and 5. How do I know what critical points are? Or let me ask that differently. Forget this picture, just in general, what are critical points? F prime equals 0 or f prime is undefined. So I look at my graph, and I've got some places where f prime is 0, at 1 and at 4. Right, because this is the graph of f prime. So when x is 1, f prime is 0. When x is 4, f prime is 0. So I've got some potential, not potential, those are critical points, potential maxes and mins. The trouble is, I don't know anything about the y values. Well, I know f of 2 is 6, but that doesn't really help for this. So what we normally do is not going to work. Jacob said it earlier, let's do an interval number line thing here. Usually we do arrows, but we know we have to stop at -1 and 5. Our critical points were 1 and 4. This is not spaced out accurately, but I want room to write what I need to write. And so this is sort of a first derivative test thing. I want to see where it's increasing, where it's decreasing, because that'll at least tell me where my potential maxes and mins are. So f prime between -1 and 1. I don't have an equation to plug it into, But all I really want to know is if it's positive or negative. So between negative 1 and 1, what's f prime? Negative, because it's below the graph. That means f is decreasing. Again, be careful. If you look at the picture, you say, well, it's increasing from negative 1 to 1. Well, f prime is increasing, but because f prime is negative, f is decreasing. How about from 1 to 4, what is f prime? Between 1 and 4, is f prime positive, negative?
Negative.
It's negative. So that means f is decreasing. And then from 4 to 5, f prime is positive. That means f is increasing. So I don't have any values, but I'm pretty sure I know what one of them is for sure. Do I know the absolute min or the absolute max based on this little picture?
Min.
Definitely the min at x equals 4, because it decreases before that and it increases after that. So that has to be, it's the only minimum we've got. So there's got to be an absolute min at x equals 4. And if we tried to sketch it, down some more, and then up, so that's the only place there's a minimum. Absolute max, well, there's two options here. Right? It's not 4, it's not 1, so it's either negative 1 or 5. And I don't have any values to plug in, but which one do you think it is?
5.
Why do you say 5?
Well, because that's where it goes back positive and this stuff is increasing again. So I think that would be 5.
Okay, so it is increasing up to 5, but it was decreasing from negative 1, so that means negative 1 had to be up somewhere. I'm going to say we don't really know enough information, but I think the best answer is negative 1, because it decreased. Put it in red for negative. All of that area, it was decreasing. F was decreasing. And then it increased for that much. So I think it decreased a lot more than it increased. So it decreased a lot and then went up a little bit. I probably should not even try to graph it, but so something changed at 4. It decreased a lot and then it went up a little bit. So I'm pretty sure my max is at negative 1, because there was more decreasing going on than there was increasing. Part C, then we'll be done. Let g be the function defined by g of x equals x times f of x. I think we've had something like that on a test before. Find an equation for the tangent line. So that means I need slope and a point to the graph of g at x equals 2. So I need g prime at 2, and I need the point at 2, and then I'll be able to write tangent line. Well, g prime, how am I going to handle x times f of x? Product rule. I'm not going to write it out because I would have the first one labeled f and then f would be labeled g, and so that would be kind of crazy. So I think just in place, the product rule is the first one times the derivative of the second one plus the second one times the derivative of the first one. I'm I'm a little nervous because I don't really know anything about f. I do have a picture of f prime. I don't know much about f, so we'll see how far we can take this. G prime of 2, you can plug 2 in for x. So 2 times f prime of 2 plus f of 2. Oh, I don't like putting people on the spot with the video recording. So, what's f prime of 2?
0.
Look at your picture. Because this is f prime. So, this tells me that f prime of 2 is negative 1. So that's why they labeled that point for us. So f prime of 2 is negative 1. That's from the graph. What about f of 2? I don't have an equation or a picture for f of 2. F of 2? How do you know it's 6? They told us it was 6. Way back when, they gave us this seemingly random piece of information, but it turns out we needed it over here. F of 2 is 6. So negative 2 plus 6 is 4. So the slope is 4. The slope of g at 2 is 4. The point, I need the y value. We're doing of g, so I need g of 2. Well, g of 2 is 2 times f of 2. F of 2 is 6. Remember, they gave us that. So that's 12. Once we make it this far, y minus 12 equals 4 times x minus 2. All right, some generic points about that problem, some of which I've already made. You will see one like that on the AP test, almost guaranteed. They'll give you a graph of f prime, and then they can ask all sorts of questions based off of that, about f double prime, points of inflection, max and mins, tangent lines. They could ask a whole bunch of stuff. So you can expect to see one of those on the AP test, and point blank, you will see one kind of like that on our test next week. And so I've given you 2 options there. We did one together, and I'll let you do the second one. But you will see one like that on the test next week. Let's talk a little bit about AP tests, because we haven't done much talking about that. Free response questions are all worth 9 points each. And you don't know ahead of time how they're going to divide up the points. Sometimes you can guess. My guess on this one is that first one is probably worth 2, because anytime they ask for a reason, that usually means there's 1 point associated with the reason. So you'd get 1 point for the answer, 1 point for the reasons. That also indicates that you could get a point for just saying this, even if you couldn't figure out where that happened. If you sort of gave the definition of an inflection point, you might be enough to get a point out of that. You'd probably have to put it in terms of f prime, but that would get you a point. I think the second piece would be worth 3 points, because it'd probably be a point for the min, a point for the max, and a point for all your reasoning in there. This one, it's hard to imagine you'd get the right answer without the reasoning, though. And then I'm guessing that last one is worth 4 points. But again, there's a whole bunch, and as a grader, they give you like a rubric that outlines what is acceptable, what's not, and how much each thing is worth. Usually they give you 1 point for just applying the correct rule correctly. So if you recognize, oh, that's product rule, let me use the product rule, like there's 1 point of that problem. I'm just guessing, but you probably get a point for figuring out what the slope is. You probably get a point for identifying the point, and you probably get a point for writing the tangent line. All that to say is, fight for every point possible on the AP test, because it takes about a 50 to get a 3, give or take. And it changes every year. But if you make a 50, you're probably going to get a 3. And so, yes, the test is hard. Yes, you're going to come out thinking, man, there was a bunch of questions I'm not even sure about. That's okay. You can still do well having missed some points and having missed some questions. All right. I want to say one more thing, but I'll put it in a separate video.